So if we have seen the electric flux, how to find the electric flux if the electric field is constant. How to calculate the electric flux, right? If electric field is variable, if electric field is variable, then how to find the electric flux? Is, listen one thing. Suppose this is the open surface. This is open surface. All right. And the electric field is variable, right? The electric field is variable. Then what will you take? You will take the elemental area. The elemental area vector, ds vector, you will consider. All right. This is the ds vector. Here the electric field, you have to take the E, and this is the angle theta. So here the electric field is different, at this point is different, different point at the different electric field is there. So we cannot write the net flux link with the surface. If this is the surface and every point the electric field is constant, right, and this is the E and this theta, this is the theta, this is area, this is, so for this easily we can write the electric flux is nothing but Es cos theta. But if the electric field is variable at different point, the electric field is different. So what will you consider? You will consider the elemental area ds. For this elemental area, the electric field at this point is E. We can write at least the elemental electric field E dot ds. You understand or not? And if you want to find the total electric flux linked with this surface, what you have to do? To find the net flux, what you have to do? You have to integrate this E dot ds. Is it clear or not? So this is the way. The total flux is nothing but E dot ds. Is it clear or not, you tell? Right. In this way you can find. Listen one more thing. This is the open surface. For closed surface, right, for closed surface, how does the closed surface? Suppose this is the spherical surface, right? Spherical surface, right? This is the spherical closed surface, and the electric field is different at different points. Suppose, so what will you do? You will consider again the ds vector like this. This is the elemental area vector, ds vector. At this point, the electric field is assumed to be E. This angle is theta. So at least we can write the elemental electric flux link with this elemental area E dot ds. Then if you want to find the total flux, this is the flux, this is the flux, this is the flux. So total flux, if you want to find, what you have to do? You have to integrate again E dot ds. Listen one thing. But the difference between this and this is the flux link with this surface which is open. But if this surface is closed, for closed surface, the only difference is that you have to put the integration. So the total flux link with this closed surface is represented by E dot ds. So in your book, you will see the two symbol to find the electric flux. This is the integration E dot ds. So it means if the surface name is S, so this is the integration of the electric field, right, for the open surface S. And if it is circulation, it is called the contour or the circulation. It means for this closed surface S, right, the integration is done. Sometime it is written and sometime it is not written. For closed surface, right, S. So this is only the difference of the symbol, right? For the open surface, we use this symbol, integration of E dot ds. If the surface is closed, we use this symbol for the integration of E dot ds. This is the symbol difference only. For the open surface, for the closed surface, the net flux will be found with the help of the integration of E dot ds, circulation of E dot ds, right? Copy this. This is the dot product, right? Copy. Let's see one example. For example, suppose this is the surface of the radius r and the electric field is constant and it is crossing like this, right? It is going and it is coming out from the surface. The electric field is constant over here, right? The electric field is what? E naught. the upward direction. Can you find the electric flux? Yes. The surface area vector, the electric field vector are in the same direction. So the electric flux is for the constant electric field is Es cos theta, right? Cos theta is what? Say 0. The electric field is E naught, and as the area of this surface is what? Pi r square into 1. So the electric flux link with this surface is E naught into pi r square. Right, this is for the constant electric field. Is it clear or not? Now what happens if the electric field is variable? For example, right, if you consider this is the surface, right, this is the surface and the radius is capital R, and here the electric field is as a function of R, right? The electric field as a function of R is given as, right, E naught into R square. Is it clear or not? E naught into R square, right? That is at here at the where, what is R? Where R is the center, R is the distance from center of circle, right? Here the electric field at this point, the electric field is constant, but as the R distance is increasing, the electric field is changing. So how to find the electric flux link with this surface? The open surface it is only, right? So how to find util? So what will you do? You to find the net electric flux link with the surface when the electric field is variable. So what will you consider? You will consider a distance r, an elemental ring you will consider, right? For this elemental ring, this is the elemental ring. The width of this ring is what? Say dr, right? So and the electric field is coming out from this ring. Is it clear or not? So the electric field is what? Say E naught into R square. Fine. So I cannot write the net electric flux link with this surface, but it's at least I can write the elemental electric field for this elemental ring of the width dr, E dot dr, right? E dr cos 0, sorry, E ds cos 0. So and to find the net electric flux, you have to integrate this E ds into 1. What is the electric field? At this point the electric field is nothing but E naught into R square. All right. And what is the ds vector? The ds vector is nothing but the ds vector is nothing but the area of this elemental ring. What is that? The area is length 2 pi r into width dr. When you will cut this and you will extend this, the area will be equal to what? The width is dr and the length is 2 pi r. So area is nothing but 2 pi r dr. So I am writing here the electric field is not constant. Electric field is E naught into R square multiplied by ds vector is 2 pi r into dr. So the E naught into 2 pi will come out from the integration. It become r cube into dr. And these rings are extended from r is equal to 0 till r is equal to, right, capital R. All these are the many rings, the small rings. You have to find the integration. So 0 to capital R, you have to integrate this, right? I am doing this side. After this, the total flux is nothing but E naught into 2 pi r ki power 4 upon 4 from 0 to r, right? E naught into 2 pi, 4 is common, r ki power 4 minus 0. Fine. So this is E naught pi r ki power 4 upon 2. So this is the total flux linked. Is it clear or not? Copy this. For example, if this is the point, this is the disk, right? This is the disk, suppose, of the radius capital R it is, and here the point charge q is placed over there. Is it clear? So because of this point charge, the electric field lines will be passing through this disk. So the electric flux, right, are passing through this. Is it clear or not? Like this. So this is the charge q at place distance x, the radius of the disk assumed to be the capital R, right? You have to find the flux linked with disk as shown in figure below. All right, like this. You understand question? So the electric field is not given, rather electric field due to this point charge you have to find at the different point, and then you have to calculate the net flux coming out or net flux linked with this disk of the radius capital R, right? Copy this. You have to consider a ring, right? A little big figure you can make. Suppose this is the disk, this is the charge q. You will consider at distance x the width of the ring assumed to be the dx. The width is what? Say dx, right? So for this ring, at least this is the q. At this point, every point, the electric field is what? Right? Every point, if assume this is angle to be the alpha, fine. If this is the angle alpha, wait for 1 minute. You may assume this is the distance r, because this separation is given x. So you will assume, and the width of the width of this small ring is dr, right? So the ds vector, what is the ds vector? Say 2 pi r and to width into dr, and the angle between them is what? Alpha. Here the electric field is what? The electric field is E. Suppose this is x, this is r. So what this distance is? It is x square plus r square. So at this point, what will be the electric field? Is nothing but kq upon r square. Right? Due to the point charge, the electric field is what? Kq upon r square. Here this is the distance r. So kq upon root over x square plus r square. This is the distance over square. Kq upon x square plus r square is the electric field. So due to this small ring of the width dr, whose area is what? Say 2 pi r into dr, at least we can write the elemental flux is equal to what? E dot ds, right? Which is nothing but E ds cos alpha, right? So this is nothing but d phi. Is it clear or not? To find the total flux, what you have to do? To find the total flux, you have to integrate this, and this is E ds cos alpha. What is the electric field you tell? The electric field is nothing but kq upon x square plus r square, right? The ds vector, the area of this elemental ring is nothing but 2 pi r into dr. And what is the cos alpha here? The cos alpha is base upon hypotenuse. The cos alpha is nothing but x upon root over x square plus r square. This is the value of the cos alpha. So I am putting the value of cos alpha is root over x square plus r square. If you simplify take the constant term common outside the integration, what is the variable in this case? This is the distance x. This x is constant. The radius capital R, okay, the capital Q and kq, 2 pi, kq into 2 pi, and this is the x, it is common. So in the numerator, it is r into dr, and here x square plus r square, x square plus r square root. Is it clear or not? Right. So this is the total flux we have to integrate. Right. First copy this, then I will do the integration. So let's see. The value of the k I am putting, it is 1 upon 4 pi epsilon naught q into 2 pi x. Right. This is the r dr, and it may be written as x square plus r square raised to the power 3 by 2. Right. So simplified this, q upon 2 epsilon naught into x, the integration, right. You may write like this. Listen one thing. The integration is can be done by two ways, by substitution or by uh, taking the tan alpha. Listen one thing, you can put the tan alpha is equal to what? Tan alpha, tan alpha is what? R upon x, right? Here the alpha is variable and this R is also variable. So if you multiply x into tan alpha is equal to R. If you differentiate this, what will be there? So x is as it is. X is constant distance from the center. So tan alpha is what? Say sec square alpha d alpha is equal to dr. So this is the differential equation between the R and the d alpha. Is it clear or not? So you may put over here, this is q upon 2 epsilon naught into x, right, into R. Listen one more thing. What is the value of the R? The value of the R is nothing but tan alpha. What is the value of dr? The dr value is nothing but x sec square alpha d alpha, right? This x square as it is in place of R, because the R I had taken the variable. R is nothing but x tan alpha ka whole square raised to the power, this is x square plus R square whole to the power 3/2, right? So this x and this is the x. So q upon 2 epsilon naught, the x cube come out from the integration tan alpha into sec square alpha, right? It is in the numerator and this is the d alpha. Is it clear? Now listen one thing, this is, I'm simplifying this first. This is what? X square plus x square tan square alpha raised to the power 3/2. If you take the x square common, so x square raised to the power 3/2 will be the common. Here 1 plus tan square alpha raised to the power 3/2. So here it will be what? Say x cube, because square and 2 will cancel out, and 1 plus tan square alpha is nothing but sec square alpha raised to the power 3/2. So it may be written as x cube and sec cube alpha. Is it clear or not? So this quantity can be written as the x cube sec cube alpha, right? I'm writing this side now. So this is the total flux. The total flux is nothing but q upon 2 epsilon naught into x. Fine. In the numerator, it is x square tan alpha sec square alpha d alpha. Fine. In the denominator, this quantity, when you will simplify, you will get x cube sec cube alpha, right? Sec cube alpha. X, it will cancel out. So q upon 2 epsilon naught. Here the tan alpha and it is the sec alpha d alpha, right? Tan alpha is nothing but sin alpha upon cos alpha, and the cos alpha, sec alpha is nothing but cos alpha. It is cancel out. So here only what will be left? Only the sin alpha will be left. Is it clear or not? So this is the total flux, right, in terms of alpha. Now you can integrate. How to integrate the alpha, right? First copy till this point, right? Then I will tell you how to put the limit, right? Copy this. So you have to integrate this alpha. Listen one thing, the ring start from here, right, like this, and then the ring are extended to this point. So this is the alpha. Alpha is the angle made from here. When the ring is at just center, what is the value of the alpha? Say 0. Then as the rings are increasing, right, the radius of the ring is increasing, the value of the alpha is increasing. So if you consider, this is the disk, this is the point where the charge q is placed. So ring start from r is equal to 0 to capital R, right? So the value of the alpha varies from theta, the value of the alpha varies from 0 to theta, right? 0 to theta. This is the angle alpha for this ring. The angle made by this line is what? Alpha. So alpha start from 0 then up to this angle. And what is this angle? Say this is the charge q and this is the theta angle. So from 0 to theta you have to integrate, right? So q upon 2 epsilon naught. The sine alpha is nothing but the cos alpha integration, cos alpha from 0 to theta. First put the upper limit. The minus sign I am taking outside, right? So first put the upper limit minus the lower limit, right? Cos 0. You can simplify this further. So this is equal to minus q upon 2 epsilon naught cos theta minus 1, or q upon epsilon naught, adjust this minus sign, 1 minus cos theta. So this is the total flux link with this, right, disk, link with this disk, right? The radius is capital R, this distance is x, and or you can say the charge q is making the angle theta, right? This is the distance x, this angle is theta, right? Like this, 1 minus cos theta. What is the cos theta? Cos theta is nothing but q upon 2 epsilon naught 1 minus x. This is root over r square plus x square, root over base upon hypotenuse, right? So you can remember this total flux formula directly. You will use this formula to find the total flux, right? It is better to remember in this way, q upon 2 epsilon naught 1 minus cos theta, right? Copy this. So let's see one example. For example, if this is the cylinder, right? This is the cylinder. The radius of this cylinder is assumed to be the r, and on the one end of the cylinder the charge q is placed, and the length of this cylinder is r root 3. Is it clear or not? So if this is the surface, this is the surface, right? Surface, is it clear? Surface S, right? Find the flux linked with, find flux linked with surface R, right? With surface S, right? This is the surface S. So this is the question. This distance is r root 3. So listen one thing. Directly the formula you can apply to find the answer. Suppose this is the r, this is the point q over there, right? And the separation is r root 3, which is nothing but equal to x. The radius is r. So first you will find this angle theta, right? This angle theta. Listen one thing. The electric flux. How to find the electric flux? This is the electric flux you have to find. The flux passing through this surface. Is it clear? So how to do that? This is r root 3. What is the tan theta over here? Right, if this is the r root 3 distance, this angle is what? Say theta it is. This is the r. Tan theta is what? Perpendicular upon base. So this is equal to 1 upon root 3, right? So this is nothing but tan theta is equal to tan 30 degree. So the theta value is what? Say 30 degree, right? So what is the flux? The flux formula is nothing but q upon 2 epsilon naught 1 minus cos theta. That's it. This is the simplest way. And the cos theta is what? Q upon 2 epsilon naught, and q upon 2 epsilon naught 1 minus cos 30. Cos 30 value is what? 1 minus root 3 by 2. So this is q upon 4 epsilon naught 2 minus root 3 is the correct answer. That's it. So in this way you can apply this formula directly, right, to find the answer, right? Copy this. So let's do one more question. Listen one thing. One question we have done in this way, like this. If it was the cube and the uniform electric field, right? If what the electric flux is coming out, the same electric flux was entering. Here the electric field was constant, so the total flux linked with this closed cubical surface was 0. I think it is very much clear. But now if the electric field is given as a function of x is equal to 100 plus 20x, is it clear or not, in I cap direction like this, then find the flux linked with cube of side, right, 2 meter, as shown in figure below, right. The electric field is now not in constant. Suppose this is the x-axis, this is the y-axis, and this is the z-axis, and this is the cube, and the side of the cube is what? Say 2 meter. Is it clear or not? This is the 2 meter. Side is 2 meter. Is it clear? Right. So you have to find the flux link with this cube. Here the electric field is not constant. In this case, when the electric field is constant, what the electric flux is entering, the same electric flux is coming out from the cube. So net flux was 0, but in this case, net flux not will be 0, right? Copy this and try. Okay, so how to solve this question? The electric field is a function of x, but the electric field is along in x direction only, right? Along in x direction mean the electric field is coming here, going in this direction, coming out from the cube like this, going here like this, going here like this, going here like this. Is it clear or not? So if you consider this is the surface, this is the face, right? This is the face is present at x is equal to 0, and this is the one face, right? This face is present at, this face is present at x is equal to 2 meter, and this face, right, is present at x is equal to 0. Is it clear or not? So if you want to write the electric field at x is equal to 2, right? So the electric field at x is equal to 2, right? You will put 100 plus 20 into 2 is equal to 120 Newton per coulomb. Is it clear or not? So, and what is the area of this surface? The area AS is nothing but 2 into 2 is equal to 4 meter square. So what is the outward flux? The outward flux phi 2 I am writing. Outward flux is nothing but E into S into cos 0. The electric field at this point is nothing but 120 Newton per coulomb, and the surface area is 480, right? Newton per coulomb meter square is the outward flux, and this outward flux is nothing but positive. Is it clear or not? But here this is the plane present at x is equal to 0, right? Suppose this is the x-axis, so x is equal to 0. So what is the electric field which is going into the surface? The electric field at x is equal to 0, 100, right, plus 0 is equal to 100 Newton per coulomb. Are you getting or not? And what is the area? Area is outward. So here the flux phi 1 link with this surface is nothing but ES cos 180, right? The electric field is what? Here 100. The area is what? Say 4 meter, the area will be the same, but it is minus 1. Cos 180 is what? Say minus 1. So minus 400 Newton per coulomb meter square is the inward flux. This is the outward flux. Outward flux is always out and it is positive. This is the inward flux, right? Outward, inward. In this case, the outward and inward flux was same because the electric field was constant. Here, the electric, as along the x direction, the electric field is increasing. So therefore, the net flux linked with cube will be what? The total flux is phi 2 plus phi 1, or you may write 480 minus 400 is equal to 80 Newton per coulomb meter square, right? This is the flux linked with this cube, right? Listen, one more thing. If you consider all the lateral surfaces, right, all the electric field at this surface is increasing, right? As the x is changing, the electric field is increasing, but all the surface vector are perpendicular to this electric field over here, right? So if you consider the lateral surfaces of the cube, right, the electric field, this is the surface area and this is the electric field. This is the surface area, this is the electric field. This is the surface area, this is the electric field. So only the fluxes linked with the electric field lines are crossing perpendicularly to these surfaces, right? So all other surfaces, the flux linked with them is 0, right? Copy this. So in the morning class we have seen that the electric flux passing through a closed, this is the cube, right? This is the x-axis, y-axis, z-axis. If the electric field is constant, what is the net flux linked with this closed cube is what? You will say it is 0. Why it is 0? Because what the flux is entering over here, the same flux is coming out from the cube, right? Not only for this cube, rather if you consider for any closed surface, right, kept in constant electric field, right? This is the closed surface. For any kept in constant electric field, net flux linked with this closed surface, is 0. Is it clear or not? For example, if this is the cube, we have found mathematically the flux linked with each face we have found, and then calculated the total flux comes out to be 0. Is it clear? Not only for this cubical surface, rather if it is a sphere, rather if it is any closed surface, if this is placed in the electric field, constant electric field, right, what the flux is entering over here, right? It is an imaginary closed surface, it is not a conductor, right? Any closed surface, the flux in and the flux out are equal in magnitude. So what is the net flux linked with this closed surface? You will say it is 0. In the same way, suppose this is the random closed surface, it must be closed, right? If it is closed, so what the flux is entering, the same flux is coming out from this closed surface. Is it clear or not? So therefore the net flux linked with this closed surface is 0. For example, I am making the figure here. Suppose this is the cylinder, right? This is the cylinder. Yeah, you can delete this. If this is the cylinder, right, this is the closed cylinder, the area is A. So if the flux is entering over here and the same flux is coming out from here, so what the flux is entering over here, this is out flux. So the outward flux is supposed to be plus phi and the inward flux is say minus phi, because here the area vector is along the direction of the electric field. Here the area vector is the opposite to the electric field, and this is the lateral surface. For example, this is the pen, this is the cylinder. So what the flux is entering here, the same flux is coming out from here, right? And if you consider this lateral surface, the lateral surface area vector is perpendicular to this surface, 90 degree, perpendicular to this electric field, right? For this lateral surface, the area is perpendicular to the curved surface. So the net flux is what? Net flux linked with this closed surface is 0. Not only for this, rather if you consider this is the cone, right? It is a cone, the closed surface, it is closed volume. So what the flux will enter, the same flux will come out from the this closed surface. Is it clear or not? So this is the thing. You understand, right? Copy this.